Welcome to section 1.2.4. We're going to be doing a function investigation challenge. So what we can do is we can graph all of these using our graphing calculators. Whether it's a graphing calculator or using the Desmos app. Either way, you can explore these graphs. So what we're going to do is we're going to look at how to graph these. So now, let's think about inputs we can't use. So if we set x squared plus 1 equal to 0, we get x squared by itself, so you subtract 1, x squared equals negative 1, and then take the square root. X equals. Now we can't take the square root of a negative, so there is no value for x that we cannot use for this one. So that's a bit of a change from the problems that we did previously that looked similar. So when x is negative 3, negative 2, negative 1, 0, 1, 2, 3. Once again, graph these, use your table. Negative 0.5, 0, 1.5, 4, 1.5, 0, negative 0.5. So we can graph those. Negative 3, negative 0.5, negative 2, 0, 1, 1.5, 0, 4, then we're at 1.5, 2, 0, and then negative 0.5. Now if you look at the graphs and look at the table, you'll see we're never going to quite reach y equals negative 1. And remember, we call that an asymptote, a horizontal asymptote for this. So that's at y equals negative 1. No matter what value we use for x, we'll never get to negative 1. We'll get very close, but never quite. So our graph is going to look like this. That's the graph. It should be a little bit smoother there, but that's the basic shape. So now, there is no vertical asymptote because we can use whatever value for x we'd like. So our domain is all real numbers. Now our range, our outputs are only going to be between negative 1 and 4. So it's an end inequality. So y goes in the middle, smaller number, negative 1 goes on the left, bigger number, the 4 goes on the right. Now we never reach negative 1, so we're just going to use a less than. But since we do reach 4, we're going to use a less than or equal to there. Remember that less than or equal to means you do reach the point. Symmetry. Symmetry means if we fold along a line, everything on the left-hand side, right-hand side are going to match up or up and down. So what this has, it's symmetric along that y-axis. If you were to fold your graph along the y-axis, everything on the left-hand side would meet up with all the points on the right-hand side. There's a horizontal asymptote. At y equals negative 1. Our x-intercepts, we're going to find them just by looking at the table. Remember, for every x-intercept, y is 0. So we can use that fact and see, all right, it's going to be at negative 2, 0 and positive 2, 0. Same thing with our y-intercept. Our y-intercept is when x equals 0, and that's going to be right there at 0, 4. And we got all of that from using the table and graphing. And the calculator really helped us get that done efficiently and quickly. Problem number 2. Y equals 1 over the quantity of x plus 3 plus 2. So in this case, remember, set x plus 3 equal to 0. X equals negative 3. So that's the number we can use. X cannot equal negative 3. So we'll graph it on our calculators or Desmos, whatever you use, and we'll make a table. Negative 5, negative 4, skip negative 3, then we'll be at negative 2, negative 1, 0, 1, 2. We could add more or take away some if we need to, but there's some values. So when x is negative 5 from the table, 1.5, negative 4, 1, 3, negative 1, we're at 2.5, and then about 2.33, I rounded. And then for 1, it's going to be 2.25, and for 2, it's going to be 2.2. Now, because x can never equal negative 3, we have a vertical asymptote at negative 3, when x is negative 3. So there's our vertical asymptote. Now, let's plot some points. Negative 5, we're at 1.5. Negative 4, we're at 1. When we're at negative 2, we're at 3. And then 2.5. And then about 2.3, 2.25, 2.2. So what's going to happen is if we keep going over, we never reach y equals 2. So there's our horizontal asymptote. So our graph is going to look like this. And this graph, once again, is called a hyperbola. So our domain, we can use any input we want as long as it's not negative 3. So all real numbers, x does not equal negative 3. Our range, we can have any output as long as it's not 2. So all real numbers, y does not equal 2. Symmetry, and don't worry about this yet, but the symmetry is along the line y equals negative x minus 1. That's a little bit more complicated. But if I were to fold along this line right here, everything would match up. But that's a lot more complicated to figure out that symmetry for that. So don't worry about symmetry for that one. Our vertical asymptote, I'm going to put VA for short. Vertical asymptote is at x equals negative 3. Horizontal asymptote, HA for short, y equals 2. Our x-intercept, I'm going to find that x-intercept algebraically, just because we haven't done it in a little bit. So once again, y is 0. So 0 equals 1 over x plus 3 plus 2. I'm going to isolate, subtract the 2 from both sides. Negative 2 equals 1 over x plus 3. And I can put the negative 2 over 1. And we can cross multiply. So you get negative 2 times x plus 3 equals 1. Distribute, negative 2x minus 6 equals 1. Add 6 to both sides. Negative 2x equals 7, divide by negative 2. X equals negative 7 halves. Now, negative 7 halves is the same as negative 3 and 1 half. Now, I only did that because I want you to notice that that's where the x-intercept is, and it looks like our graph matches up with that. So we can just put negative 7 halves, 0. And our y-intercept. Remember, for our y-intercept, we're setting x equal to 0. So y equals 1 over 0 plus 3 plus 2. So y equals 1 over 3 plus 2. We have to add those fractions. So y equals, and now that 2 over 1 becomes a 6 over 3. So you get y equals 1/3 plus 6/3 is 7/3, which is the same as 2 and 1/3, which does look like it's about right because 2 and 1/3 is up there. So we could put 0, 7/3 for our y-intercept. On the next page, g of x equals x squared plus 2. Now you see that x squared, it's a quadratic. We can graph it on the calculator if you'd like to, x and y. So I'm going to pick some values, negative 3, negative 2, negative 1, 0, 1, 2, 3. And then from the table, or if you just do the mental math, 11, 6, 3, 2, 3, 6, 11. So if we plot those points, negative 3, 11, just a little bit off the graph, negative 2, 6, negative 1, 3, 0, 2. So our parabola is going to look like this. Now, our domain for this parabola, all real numbers. Our range, we never go below 2, so y is greater than or equal to 2. It does have symmetry. If you fold along that y-axis, everything touches. So y-axis is our symmetry. Our x-intercept, it never crossed the x-axis, so there is none. Our y-intercept is going to be at 0, 2. And we can see that right there because x is 0. And there are no asymptotes for this problem. Problem number 4, it's an equation in standard form. We're going to get this equation into slope-intercept form, or there's actually a quicker way to do it. We can actually graph this using intercept. So I'm going to show you that. That's something new. So what I'm going to do is I'm going to find my x-intercept by setting y equal to 0. So 2x minus 3 times 0 equals 12. 2x equals 12. Divide by 2. X equals 6. So my x-intercept is at 6, 0. Now the y-intercept, set y equal to 0. So, I'm sorry, x equal to 0. So 2x minus 3, try that again. So 2 times 0 minus 3y equals 12. Negative 3y equals 12. Divide both sides by negative 3. Y equals negative 4. So our y-intercept is at 0, negative 4. So here's my y-intercept, and here is my x-intercept at 6, 0. And if you remember back from Algebra 1, you only need 2 points to draw a line. So that's what I'm going to do. I'm just going to draw a line through those 2 points. And there's my line. So I have my x-intercept and my y-intercept, and I have my line. Now I need my domain, all real numbers. Range, same, all real numbers. There is no symmetry here, and there is no asymptote. If you were to write that equation in the slope-intercept form, you would get y equals 2/3 x minus 4. If you notice, you'll get the same exact graph. And finally, problem number 5. K of x equals 1 over x squared plus 3. So x squared equals 0, because we want to find out what value we can use. If we take the square root of both sides, you get x equals 0. So x cannot equal 0 here. So that's where my asymptote, my vertical asymptote, is going to be. I can just do that right away, because I know that's where it's going to be. So graph it on the calculator and get the table. I'm going to pick some values around 0, negative 3, negative 2, negative 1, skipping 0 because we can't have it, 1, 2, 3. So I'm going to round my values. It's about 3.1, 3.25, negative 1, 4, positive 1, 4, 3.25, and 3.1. So we're at negative 2, 3.1, 3.25, sorry, shift it over, 3.1, 3.25, 4, 4, 3.25, 3.1. Now, if you look at the table, you're never going to get y equals 3. You're going to get close, but not quite. So that's our horizontal, y equals 3. And there's our graph. This is not a hyperbola. Now, the domain, all real numbers as long as x does not equal 0. The range is a little bit different. We never get to 3, but it goes all the way up. So our range, y, is greater than 3. Our x-intercept, if we look at the graph, we never cross the x-axis, so there is none. Our asymptote is along the y-axis, so for our y-intercept, there is none as well. Our vertical asymptote, as we spoke about before, is at x equals 0, and our horizontal asymptote, y equals 3. Once again, this relied quite a bit on the graphing calculator, or Desmos. If you have any questions about those, please make sure you contact me and we can work on that together. Thank you.